Good evening, students. So we'll continue discussing the NEET discussion paper. Okay, right? So I think yesterday, last week, the number is 16, right? Now we'll start doing easy questions. So I have written everything, right? So 17, see the question? 17. Newton per meter square is the unit of. Newton per meter square is the unit of. So we'll see all the units. So it will be easy for you for the remaining questions, right? So first option they give as energy, second option momentum, third force, and the fourth one is pressure, right? So what is the unit of energy? Today I'll ask more questions, try to answer yourself. Okay. So what is the unit of energy? Already we discussed in the last class, right? So Joule is the unit of energy, right? And next, momentum. So what is the formula? Mass into velocity, right? So kg meter per second, right? So kg meter per second is the unit of what? Momentum. Next, what is the unit of force? Formula mass into acceleration. So kg meter per second square, right? So kg meter per second square is the unit of force. Now, what is the unit of pressure? Pressure formula. Answer yourself. Force per unit area. So, what is force again? Kg meter per second square divided by square meters, right? So the square meters will go to the numerator. So I can write it as kg meter to the power minus 1 and second to the power minus 2. Or one more unit for force. So kg meter per second square, we can write it as Newton also, and here also we can write kg meter per second as Newton. So another unit is Newton per square meters. So all the things I have written, it will be useful for the further questions. Now according to the given question, Newton per meter square is the unit of what? Is the unit of pressure. Is the unit of pressure. Clear about the point? So can I move forward? All right. So unit of surface tension. I think this formula we got in yesterday's class also, right? So surface tension. What is the formula? Force per unit length. Surface tension, force per unit length. So force in the sense Newton, just now we have seen, and length in the sense meter. So it will be Newton per meter is the unit of surface tension, SI unit. If they ask about CGS, you can write it as dyne per centimeter, right? So dyne per centimeter will be the CGS unit, SI unit will be Newton per meter. Next, and SI unit of momentum, just now we have seen, so that's why I didn't give any space. Say SI unit of momentum, mass into velocity, it is nothing but kg meter per second, right? So SI unit of momentum is nothing but kg meter per second, mass into velocity, right? And next, 21 million electron volt. Is that clear, right? I'm not going fast, I think so, because questions are easy. So I have written, it will be easy for you. We can go a little faster. So we have to cover 60 questions, right? So 1 million electron volts. See the option million. Whenever if you see million, it is 10 to the power how much? 10 to the power 6 electron volts. 1 million. See the options, what they give. So 1 million electron volt is equals to, they give 10 to the power 5, 10 to the power 6, 10 to the power 4, 10 to the power 7. So million, in the sense, it will be 10 to the power 6. Sometimes we call it as a mega electron volt. That also indicates 10 to the power 6 electron volts. So million, 10 to the power 6, in the order we have to write. Okay. So next, 21. Okay, so 21. So erg per meter can be the unit of. See, erg per meter can be the unit of force or momentum or power or acceleration. Indirect. CGS, one CGS thing and one SI thing they gave, but okay, if you know the formulas, we can do it easily. So force in terms of this erg in the sense unit of what? Unit of energy, whatever the type of energy. So energy and meter per meter in the sense what? With respect to distance. Now you have to think like this. What is that? It is energy per distance. Energy divided by distance. That which one we will get? to see. Already, I think work done formula we know. What is work done? Force into displacement. So force which is equals to work done divided by displacement. Yes, we got. So work done is nothing but force into displacement. We discussed in the last class also. Work done is the dot product of force and displacement. What is dot product? We'll see in the next upcoming classes. Okay. So force I can write as work done by displacement. So work done is nothing but energy, and displacement is nothing but the distance or displacement per meter. So directly I can go for force. No need to discuss about this. Why? Because they won't be in an order of energy divided by distance. So momentum you can write as mass into velocity. But if we change in terms of energy, it won't be like this. We won't get this unit, right? And next, power rate of work done, we know that one also. If you convert, see, work done by time is there. So what we want, work done by distance or displacement we want, but here time. So if you change also, we won't get in this format. And next, acceleration. So acceleration is nothing but rate of change of velocity, right? So if we convert this again, we won't get in this format. So force will be your correct option. All right. Next, unit of potential energy. I think no need to discuss again. Unit, just now we have seen potential energy. That is also a type of energy, right? So if that is also a type of energy, that is nothing but I can write it as joule. Right? According to the options, you have to change, but different things will be there. Unit of potential energy, you can write it as joule. So another way of writing this joule energy dimensional formula ml square t to the power minus 2. So based on this, another unit can I frame or not? So what is the m mass kg and l length? So it will be meter square per second square. So as a unit, okay, we can write this. Or if you want in terms of CGS unit, again you can change gram, centimeter square per second square. It depends on the options. We can change. Okay. So next, following, which of the following represents a unit of volt? Volt. I'll write a formula for volt. I think you got in your 10th class, might be, and you'll get in 12th again. Okay. So unit of what? Unit of volt. So volt is nothing but work done per unit charge. Try to remember what do you mean by that work done, what do you mean by that charge and all. You'll get in the 12th. Don't worry about that. If you know, well and good. I think you got in your 10th class. So potential is nothing but work done per unit charge. So following represents a unit for volt. So only one formula will be there for volt? No. So already I think in the yesterday's class we have seen another concept for volt. What is that? In terms of power. Power is VI. So from here also we will get the unit of volt. What is that? P divided by I. So you have to see everything. When you will get this type of flexibility after completion of 11th and 12th syllabus, you will be in a position that you can write all the formulas. Then you can do this type of questions. Now at a starting stage, at an instant, if you want to do, that will be a little difficult. Don't worry about that. Okay. So volt I can write as power and current, right? So power is nothing but watt, and current is nothing but unit of current is ampere. So joule per second is not possible. Joule is okay, but here charge is here. Charge unit is coulomb, right? So joule per coulomb is correct. So joule per second is wrong. So watt per ampere is correct, and watt per coulomb is wrong. Joule per coulomb is correct. Coulomb, fourth option, I think it's not visible to you. So fourth option, what they gave is coulomb per joule. That is wrong. What is correct? Joule per coulomb is correct, right? So second option will be your correct option, right? Okay. Next, read the next questions. Okay. Next. 24. So what is that? Kilowatt hour. Kilowatt hour is the unit of. Okay. So next 25. So which one of the following is a derived unit? So I think we know about fundamental and derived units, right? So first option they gave as mass, and the second option as length, and the third option time, and the fourth option volume. I think you know this, no need to waste more time. Next 26 I'll discuss. First I'm trying to write some questions. So dyne per centimeter square. 26 I'll discuss. So dyne per square centimeters is the unit of, is not a unit of, is not a unit of.